Now, as we saw in the previous clip, if this is my P substrate and this is my SiO2 layer, this is the area where I want my nwell to be. The next thing what we are going to do is put a photoresist, which is a light sensitive polymer, and it will soften when exposed to UV light. This is nothing but a photoresist deposition which we have done. Next in the step is mask. Use a mask. In this case, we want an nwell, so this is an nwell mask, correct? This mask you can get from the layout or physical design, and wherever the mask is transparent, in this case it is, right, because we want our nwell to be present here, that part of the photoresist will get softened. So this part of the photoresist will be softened, whereas this part of the photoresist would be hardened, correct? And we saw what we are going to do next is the softened part of the photoresist needs to be removed, right? So we will call this step as photoresist removal. We saw that this was a softened part, so we removed that part of the photoresist. If you pay attention to it and if you have watched the previous clip, you will understand what I'm talking about. The hardened part is still present. Remember that. Now this is the area where you want your nwell to be, correct? So you don't want your oxidation, or you don't want your SiO2, which is present through oxidation, to be present. So now what you are going to do is remove this SiO2 layer as well. So PR removal happens through some acidic solution, or photoresist removal through some organic solvents or acidic solution. The next is removal of SiO2 underneath the softened photoresist. This is done through the use of hydrofluoric acid. So now there was SiO2 layer present here, which I have removed, correct? Now I don't need this extra photoresist, so I'm going to remove the hardened photoresist also. This is what I have done. Here there was an additional photoresist, now I don't need it, so I'll remove this hardened photoresist in this case through the combination or a mixture of acids. So now I'm all set. The area is open for my nwell to come in. Now I will use my process of diffusion or ion implantation, and I will just deposit my nwell or n-type impurities here. So I hope that makes sense. So once I have the nwell, correct, I have purposely shown it like this, but this is not to be the case. Technically it's exactly where you want your nwell. It's going to be this. It's not going to be this at all, mind you. So don't make such errors. But yes, sometimes in diffusion and ion implantation the impurities might get scattered. Again, I am not getting into that right now. So the next step, once I have my nwell, if you go back, see your nwell is done. And at the start we discussed that this was your substrate and you wanted your nwell, which you have achieved. Now the only part which is unwanted is this SiO2 layer, which is generated through oxidation. So let's remove that also with hydrofluoric acid. So removal of additional SiO2 using hydrofluoric acid. So we are set now with the nwell. Now I want to identify the areas where my polysilicon is going to be present. So I am saying that here is my SiO2 and here is my polysilicon, or the gate, SiO2 and polysilicon. This is what I want. So we discussed this in the basic clip. What we'll do is we'll deposit SiO2, a thin oxide rather, which if you see here I have deposited. This is a thin oxide, correct? And over that, using a CVD process, chemical vapor deposition, I will deposit poly. So this is a thin oxide over which I have deposited polysilicon. And then we have already seen this in the previous clip. Using polymask and lithography steps, we can easily achieve where the areas where we want SiO2 and polysilicon to be present. Again, for this we have discussed this in the previous clip, the in detail steps from step 10 to step 11. Once that is done, now I want to diffuse my impurities, right? Suppose let's say I want to diffuse my n-type diffusion or n-type impurities. So here is one area where I would want, probably I would want it here, and an n-well where the PMOS would be fabricated, I need to connect well to VDD. So here is the one area where I would want my n-well. So we discussed these steps also in details. What we do is first deposit SiO2 again, correct, through the oxidation process. Fine. Once that oxidation is done, we know that we'll do masking, photolithography, and we'll do n-type diffusion. So we'll have these openings. We see all the series of steps, right? Deposit SiO2 layer, then deposit the photoresist, expose it to UV light, so remove the softened photoresist, remove the SiO2 layer beneath it, then remove the hardened photoresist, then diffuse your impurities, and finally go ahead and remove the excess SiO2 layer. This is all what is shown in the steps which are present, correct? So here I got the openings where I can diffuse my impurities. This is what I have diffused my impurities N-type, and here I have removed the excess SiO2 for hydrofluoric acid. Remove excess SiO2, correct. So we can also call that as oxide stripping. Now similarly we can explain all the steps of P-type diffusion as well, correct. I hope you understand this now. I'm not going into details. This is the areas, and similarly we diffuse P-type impurities as well. Now everything is ready. We just need to make external contacts through metallization, and metallization will follow a very similar pattern to polysilicon deposition. So what we do is we deposit thick fill oxide over the entire area, which is shown here in yellow. This thick fill oxide is deposited in the entire area except for the regions where you want to make your connections. So you can see that, and there is a specialized process through which we can do that. Once that is done, deposit your metal through a step called metallization on the whole wafer. Now we know that using photoresist and lithography you can remove the excess of metal. Remove the excess metal, just keep it till there. So remove the excess metal from the wafer. Finally, this is what is going to happen because the metal was removed and you made your contacts. If you see this is the area where you wanted your contacts to be. That's what I have shown here, correct? So this is nothing but a classic understanding of N-well process, very straightforward. Similarly, we can understand P-well processes as well.